Chapter 5, Section 2 deals with bisectors of triangles. So we have a few definitions in here along with two theorems. Okay, so first thing, concurrent, all right, or concurrent lines. Concurrent is a term used to describe when three or more lines meet at one point. So right here we have line J, L, and K, and they all meet at point A. So all three of these lines are concurrent because they meet at one point, and the point of concurrency is the point where all three of them meet. So point A would be the point of concurrency for J, L, and K here. Okay? So using those two definitions, we're going to look at how they apply to triangles. Alright, so first thing, okay, the circumcenter of a triangle is found by drawing the perpendicular bisector of each side. Okay, so right here for triangle ACD, okay, triangle ACG, I've drawn the perpendicular bisector. So these two lines are congruent, these two lines are congruent, these two lines are congruent. All right, perpendicular, perpendicular, and perpendicular. So BD is a perpendicular bisector of AC, DE perpendicular bisector of AG, and DF is a perpendicular bisector of CG. Notice all three of these lines meet at this one point D. Okay, so D here is the circumcenter. Okay, D is the circumcenter. It is found by showing the intersection point of the perpendicular bisector for each side. So the theorem we have for this. The circumcenter theorem says the circumcenter of a triangle is equidistant from the vertices of the triangle. So from D to A, and from D to C, and from D to G, those are all the same distance. Notice DA 7.97, CD 7.97, DG 7.97. So the circumcenter is equidistant from the vertices. That's the circumcenter theorem. And you find the circumcenter by drawing the perpendicular bisector of each side. Okay, now, the circumcenter of a triangle isn't always found inside of the triangle. Okay, if you notice here, I have three acute angles. So if I have a three acute angle triangle, so an acute triangle, it's going to be located in the center. Okay, the circumcenter for a right triangle, if you notice here, perpendicular, all right, so that's the midpoint, that's 90 degrees, midpoint, 90 degrees. So the circumcenter for a 90 degree, a right triangle, is located on circumcenter is located on hypotenuse. Okay? So for a right triangle, 90 degrees here, circumcenter is located on the hypotenuse. Now notice the same theorem holds true from the vertice to the circumcenter. So D here would be the circumcenter. C to D, 9.23. E to D, 9.23. A to D, 9.23. So the theorem still holds true. Now if it's an acute triangle, the circumcenter is located inside. Right triangle, circumcenter is located on the hypotenuse. So for an obtuse triangle, the circumcenter is located outside. Okay, it's located outside of the triangle. So here, once again, it's the bisector. So that's perpendicular. Bisector here, 90 degrees. 90 degrees. This is also the bisector. All right, so G would be the circumcenter of triangle ACF. Okay, and notice A to G, 19.92. C to G, 19.92. F to G, 19.92. So the theorem holds true that the circumcenter, okay, G here, is the same distance from all three vertices. Okay, and we find the circumcenter by drawing the perpendicular bisector to the sides. Okay. Right. Now, the circumcenter is also the center of a circle that has the triangle inscribed in it. So inscribed means that the vertices are inside the triangle. So this triangle is inscribed. Now if you notice, if I take this here and I move the triangle around, so now I have an obtuse triangle. So the circumcenter is outside the triangle. I have a right triangle here. So the circumcenter is on, and then I have an acute, so it is inside. Okay, if you can notice here, so that's an even better image. Okay, obtuse triangle, circumcenter is outside. Notice the angles here; these are all 90-degree angles, so it's a bisector, or so it's a perpendicular, and they bisect at the midpoint. Notice the distance from the circumcenter A to the vertices G, C, and E. Anywhere I move it, they all stay the same distance to it. Okay. All right. The incenter of a triangle, okay, the incenter of a triangle is the point of congruency of the angle bisectors of the triangle. Okay, so incenter, think of it as inside. No matter what shape it is, it's always going to be inside. So this angle is congruent to this angle. This angle is congruent to this one. And this angle is congruent to this one. These are the angle bisectors. Okay. Now, the theorem says that the incenter of a triangle is equidistant from the sides. So from this point E is the incenter, to this line AG. And remember, distance is perpendicular. So I is directly across, so the distance from I to E is 3.2. From E to J, 3.2, and E to H, 3.2. If I move the sides around, notice the distances still stay the same no matter what I do with the angle bisector. And notice, look at the center. It's always inside. The incenter is always inside of the triangle. So I draw an angle bisector, angle bisector, angle bisector that all meet inside the triangle. And the distance from this side to the incenter is the same as the distance from this side to the incenter and from this side to the incenter. Okay. If you notice, all right, the incenter here, okay, I have this triangle and the angle bisector here, here, and here. Notice they all run through the center point of the circle. So the incenter, okay, is the center point of a circle inscribed inside of a triangle. Okay, so the circumcenter is outside. The circle is outside of the triangle. The incenter, the circle is inside of the triangle.